Hi guys, so today we are going to be looking at this question that is based on analytical geometry. So we have question 2 here that reads as follows. It says that in the diagram below, we have point P, Q, R that are vertices of a triangle such that PQ is equals to QR and PQ is perpendicular to QR. T is a point on PQ such that T is the midpoint of PQ. S, it is the point of intersection of RQ and the x-axis, while V is a point on the x-axis such that Q angle QSV is equals to 121 degrees. And then we have angle QPS, which is equals to theta. Right, so this is the triangle that they are referring to. This is the point T that they are referring to. That point T, it is a midpoint of PQ, right? And then we also have this angle here, angle theta here, that is the angle from the x-axis to the line PQ. And then another thing, we have this angle here, which is equals to 123 degrees, right? Which is also an angle from the x-axis to the line QR, right? So those are some of the things that we have in this diagram here. So let's first read our first question here. So our first question here, it says that we should determine the length. We should determine the length of PQ, right? So they want us to determine this length here. Let me quickly highlight this length that they are referring to. We must calculate this length here, right? We must calculate this length here that they are referring to, and then let's see how can we calculate. We know the coordinates of Q, we know the coordinates of P. So meaning that we have point P, we have point Q here, meaning that we can use a distance formula in order to solve or to determine the length of PQ. So we have this, which is PQ here, that is going to be equals to YQ here, YQ minus YP squared, then we say plus here, and then we say xq minus xp squared here. So this is what we have at the moment. So now it is time that we do what? We substitute into our equation. What's the value? The y value of q. The y value of q is 3. The y value of p is 0. Then say squared. Then the x value of q is 6. Then the x value of p is 1. Then we square here. Then we say that we have pq here. We know that from the first bracket it's 3 minus 0. 3 minus 0, which is 3. And then 3 squared, which is going to give us 9. We know that from the first bracket here we're going to get 9. Then 6 minus 1. 6 minus 1 is 5. And then 5 squared is equal to 25, right? So that we have P here, PQ here. In this case, it is going to be equal to the square root of 34, right? So remember, since here they said that we should calculate the length, it is important that whenever you calculate for the length, you specify the units, right? Because here we are not given that it's centimeters or kilometers or whatever unit that they might give you. In this case, we know that we are not given any units, so it is important to specify that this is what this is, or these are units, right? So which means the value of the length, or the length of PQ, it is equal to the square root of 34. Why do we leave our answer like this? Because remember that they said that we must leave our answer in the simplest set form, right? So we don't have to round off this particular answer here. So now let's move on to 2.1.1.2. So this is what we have here. So 2.1.2 says that we should determine the gradient of PQ, right? So we have to determine the gradient of PQ. We can see that it's still the same line that we have on our previous question. So for now we should determine what? We should determine the gradient PQ, right? So which is that line there. So from that, what do we know? We still have those coordinates of P, we still have those coordinates for Q here. We know that we use those coordinates in order for us to determine what? The gradient. We know that there's this formula that says that y p q, right? So y p q, or mpq, I mean, it says that the gradient of pq, right? Which this is the same as saying that yq minus yp divided by xq minus x p for this one here. So we know that what's the y value of q? The y value of q, it's 3. The y value of p, it's 0, divided by the x value of q, which is 6, minus the x value of p here, which is 1. And then from here now we can see that 3 minus 0, it's 3. Then 6 minus 1, this is equals to 5. So this is how we actually calculate for the gradient PQ in this question here. So now we go on further and look at 2.1.3. So 2.1.3, they said that we should calculate for the coordinates of T, right? Remember they said something about T in our statement, right? They said that T is a midpoint. So T is a midpoint of PQ, right? So meaning that this distance here, it is equals to this distance here, right? So how would we look for this particular coordinate here? So as you can see that here we know the coordinates for both of these points, right? So those that are at the end. So meaning that we can just say that T, use the formula T, it's equals to xp plus xq divided by 2, and then we have yp plus yq divided by 2, right? So these will enable us to get the coordinates of T. So we say that T is equals to, here in this case we are going to have 1 plus 6 divided by 2. So this is going to give us the x coordinate, or the x value of the coordinate T, right? So the x value of coordinate T will be equals to this, while this is going to be it is going to be equals to the y value of this point here. So we are going to have 0 here, which is the y value of P, plus the y value of Q here, which is 3. Then we divide this by 2 as well. So from this we know that 1 plus 6 we are going to get 7, right? And then 7 here, we are going to get 7 here, and then 7 divided by 2, we know this is 7 over 2. And then from here we have 0 plus 3. 0 plus 3, we know that this is 3. And then 3 divided by 2, we know this is going to give us 3 over 2. And then this is how we actually get our coordinates for point T here, which is a midpoint. Hence why we used this formula here, because we understand that T, it is a midpoint of PQ, because that's what was said on our statement. So now let's move on to 2.1. Let's see what's the next question here. So now we have 2.2.1, right? So decided to bring back the statement again here so that we can analyze this statement with the diagram together. So now we have what they said, that we should calculate the area of this triangle here, the triangle QTR. So let's highlight the triangle that they are referring to. They said this is triangle QTR, right? So this is the triangle that they are referring to, right? So we can see that triangle QTR, we can see that this is a right angle triangle. This is the first thing that we notice from this. So this is a right angle triangle, right? Right, so remember, we can say this since this is from what this, it is clear that we have what we have a right angle triangle here. So from this now we move on to analyzing the whole question. Now remember, they said something previously here, particularly here, that PQ, it is equals to QR. So they said this side here, it is equals to QR here. So remember, what do we know? We know this length here. We now know the length of PQ, that the length of PQ, it is equals to the square root of 34 units, right? So this is what we have. And then let's take a look. It means that this side here, as well, this side, the whole side here, it is also equal to 34, square root of 34 units as well, right? So what other side can we determine from this? Looking at this point here, or looking at this, particularly this statement here, let me underline it. It says that T is a midpoint of PQ. And then what do we get from this? We are getting the fact that it means that PT, or the distance PT, or the length of PT, is equal to the length of TQ here. It means that they have the same length, and T, it is a midpoint. How can we get the length of TQ, since that's what we are interested in? So since T, it is a midpoint, and then we know the total length of PQ, we can say that TQ, it is equals to square root of 34 divided by 2. Right, so this is what we have. So this is the length of TQ, right? We divide the total length by 2. So since T, it is a midpoint, so now we know that this length here, it is going to be equal to square root of 32 divided by 2. Then here we have the square root of 32 divided by what? Divided by 2. So these are the lengths that we have for this particular triangle. So now we know that we have a right angle triangle. Or how do we actually calculate for the area of a triangle? For the area of a triangle, we know that we use what? We use the formula that area of triangle, it is going to be equal to half times base times height. So since this is a right angle triangle, and then these sides are adjacent side, we can simply say that, let's have a look at this. So this can be our base, and this can be our base as well, or this can be our height, and this can be our height as well. So we are only going to choose one side. So let's choose TQ to be our base. So we know that we are going to make TQ our base. This is what this is, H, which is the height. The height here in this case, it is going to be equals to QR, right? QR. And then from these now we substitute. So we are going to say 1 over 2 times TQ. TQ, it is equals to the square root of. So remember guys, this, it is supposed to be the square root of 34. The square root of 34 divided by 2 multiplied by QR. So what's the length of QR? The length of QR, we discussed that the length of QR, it is the square root of 34, right? So let's fix here. It is supposed to be 34, and then here it's supposed to be 34, right? So this is what we have now in this case. We know what's going to happen. We know that 1 times the square root of 34 is going to give us 34, square root of 34, I mean, and then square root of 34 multiplied by the square root of 34, this is going to give us 34, right? It's going to give us 34. And then from these, what else do we know? We know that 2 times 2, it is going to give us 4. We know that here there's 1, and then 4 times 1, we are going to get 4 as our answer here. So this is our answer here. And then remember, we can round off this answer here to what? To 8,5 units, right? Units what? Since this is an area, if you're calculating for area, it will be units squared, right? So this is how we actually calculate for the area of triangle QTR. Alright, so now we are on to our next question. It says that we must determine the size of theta, which it is the size of this angle here, which it is an angle from the x-axis to the line PQ here. We can see that this, it is an angle, and then one thing that we can see that here, to solve this particular question here, let's look at this. We have P, let me highlight this, we have P Q S here, and then we have what? We have this here, we have this here. We can see that P Q S, they make up what we call what? A right angle triangle, right? And then they make up a right angle triangle from this. So what else can we see about this? We can see that this angle here, we can see that this, it is a 90-degree angle, right? It's a 90 degrees angle. And then we know that this is angle theta. And then we can see that we have an angle which is 121 degrees here, right? So this angle here, it is an exterior angle, right? So the obvious way, or the right way, which we normally use, that in this case we have this angle and this angle here, which is the 90 degree plus the theta angle. We know that this is going to give us what? This is going to give us 121. So let me quickly show you how, or what I'm referring to. We know that we have this angle here, which is the angle which is 90 degrees. Let me represent this. We have angle P QS, which is the 90 degree angle, plus angle Q plus angle QPS, right? So this is the angle theta. This is going to give us 121 degrees. The reason being is that it is what? Exterior angles of a triangle, right? So let's take a look at this. We have angle PQS. We know that this is equals to 90 degrees plus angle QPS, or angle PQS here, and then here we have QPS. So QPS here, it is equals to angle theta, right? So QPS, it is this angle here, right? And then another thing that you should take note of, it is that PQS, it is this angle here, which we know that it is equal to the 90 degree angle, right? So we know that this is going to be equal to 1 21 degrees. And then from this we know that we can do what? We can just transpose everything towards to the left, and then we leave the theta so that we make theta the subject of the formula. Then we have 121 here minus 90 degrees, and then from here we have 121 minus 90 degrees, and then we can just simply put this on our calculator so that you get 121 minus 90 degrees, which is going to be equal to 31 degrees. So remember, this is just one way in which you can do this. And then another way to look at this question here, it is that you can see that you have this angle here, which is 121 degrees, right? And then from this we also see that we have another angle here, the angle that is inside the triangle, right? So looking at this angle here and this angle here, we know that when we add the two angles, we expect to get what? We expect to get 180, right? So we know that we expect to get 180 from this. So meaning that we can first get this size here. We know that when we add this angle, it is called, the angle that I'm referring to, it is angle QSP, right, which is this angle that I've highlighted in blue, plus this angle which is 121 degrees. We know that this is going to give us 180 degrees because we have what? We have angles on and straight line, right? So this is what we have. We know that angles that are on a straight line, they will add up to 180 degrees. And then from these we will do what? We would say that we have QPS, we have QSP, which is 180 degrees minus 121. And then we know that from this we can see that from here now we can also get the same value here. We get the same value from this. You see 180 minus 121. We can see that we get and then from these now we know that it is the angle that we highlighted in blue, which is angle QSP. We said that this angle here, it is equal to 59 degrees. Therefore, if we were looking for the size of theta here in this case, what were we going to do? We know that we are going to say that it's angle QSP here plus angle, which is, we know that it is this angle here, plus this angle which is theta. We refer to this angle as what? As angle QPS. Angle QPS plus which angle? Plus angle PQS. Plus angle PQS, right? So this is what we have here. So this is what we have. So let me just erase this part here so that I write it neatly. So we have angle QSP here, and then this is what we have. We know that this was going to add up to 180 degrees, which is what? We know that this is the sum of angles in a triangle, right? So we know that QSP here, we have just said that this is equal to 59 degrees, and then while QPS we know that this is theta, and then PQS, let's look at PQS. It is this angle here, which is equal to 90 degrees, and then from these we know that this is 180 degrees. So that we know that continuing here, we know that we are going to make theta the subject of the formula, and then on our calculators we are going to say 180 minus 90 minus 59 as well, so that we get our answer here as 31 degrees, right? So that's what we are supposed to do here in order to get what theta. We can see that we have found, or we got the same answer here using different approach, right? So the most important thing is that as long as you are using whatever that we are using in maths to find your answer, you are always going to get your answer. As long as you have applied everything correctly here, you are going to get the same answer here. So always remember that whenever you write such statements, always state the reason why you said this is equals to 180. Always state that this is equals to 180 because these are sum of angles in a triangle, whereas this was equals to 180 degrees, and then we had what angles on a straight line. So always state the reason, guys. So that's it for this question. So let's move on to our next question here. All right, so 2.3 reads as follows. It says that determine with the reasons, right? So the gradient of the line through T, which is this point here. You must determine the line that passes through this point T and the midpoint of PR. We know that the midpoint of PR, it is going to be somewhere here. So we are looking for the gradient of this line segment here from T to the midpoint of PR here. So let's analyze this situation that we are having. We know that this means that, okay, this is equals to this. At the same time, it is saying that this, it is equals to this segment, this side here. So let's take a look at what we have. If we're to draw a rough sketch of what we are having now, it's more like we are having a triangle like this, whereby we have this here, and we have this here, this here. Right, so it means that this particular line, it joins the two midpoints of the two sides in a triangle, right? So now what can we say about this? We can say this, it is a midpoint of what? It is a midpoint theorem, right? Since we have what? We have a line segment that is joining two midpoints of the two sides that are in a triangle. So what do we know from the midpoint? We know that this side here, this side, I'm referring to this side here, this side or this line segment will be parallel and have the third side, which is this side here. So it means that this side here, it is parallel to this side here, right? Why? It is because of midpoint theorem that states that the line segment joining midpoints of any two sides of a triangle, it is parallel to the third side, and then it is also equal to the half of the length of the third side, right? So but what we are interested in this question, it is the fact that this, it is going to be parallel to this, right? So what we are going to say that it is that the line through T, line through T and midpoint of PR, right? So we are saying that the line through T and midpoint of PR, it is going to be, it is parallel, it's going to be parallel and have the third side, right? But then in this case, because we are only interested on the parallel aspect, we don't have to mention this, right? So we only have to mention this, that it is parallel to what? It is parallel to line QR, right, from our triangle here. And then from this, let's have a look at this. What do we mean when we say this is parallel to this? So when we're saying that this line here, it is parallel to this line here, it means that their gradients are the same or they are equal, meaning that if we can get the gradient of QR, right, if you can get the gradient of QR, therefore we can say what? We can say the gradient of this line segment here that is joining the two midpoints, it is equal to the gradient of QR there, right? So we can say that we can first determine the gradient of QR, right? So we determine the gradient of QR. We know that we are going to use the fact that YR minus YQ divided by XR minus XQ, right? So from this now we know what's the Y value of R. The Y value of R is -2, and then the Y value of Q here in this case it's 3, and then we divide this by XR, which is the X value of R. The X value of R, we say it's 5, and then the X value of Q here in this case it's 6. Then we divide these like this, and then we say -2 minus 3, -2 minus 3, you know that this is going to be -5, and then 9 minus 6, this is also going to be equals to 3, right? So that the gradient of QR is equals to this. So meaning that this gradient as well, we can say that we can now conclude that therefore the gradient, right, the gradient of line through T and midpoint PR, right? Midpoint PR is equal what? It is equal -5/3, right? We know that since the two lines are parallel, right? So that's what we have here in this case. So that's how we actually determine the gradient of that particular line. We use the midpoint theorem, right? So you use the midpoint theorem to determine this particular answer for this question here.